grade 12s. In today's lesson, we are going to be revising organic chemistry, that section that probably for some of you haven't looked at since January or February. So it's really important that we go through this. Now remember, grade 12s, the thing about organic chemistry is they're always going to ask you the same type of questions. Your first question is always going to be on naming, identifying functional groups, drawing things, maybe a little bit of reactions. Your second question, or maybe your third, the next two, it depends on the examiner, will be on things like intermolecular forces, boiling, trends, all of that sort of stuff. And then, of course, there'll be a question on the reactions. Now, the reaction question is very often done as a flow diagram. Okay, so what we're going to do is we're going to start straight away, because all we're going to do today is questions like we did with the physics. So here we have a question, okay, and what we have here is we have seven, apparently I can't count today either. So we have 6 organic compounds, okay, so there's the organic compound, so this would be like what you'd get in an exam. And then here's the questions. So what I want is, I want you to take those 6 compounds, and I want you to write down the letter that represents a compound that has a carbonyl group. Okay, so I want the carbonyl group. I want to know the one that is an alcohol, and I want to know the one that is a chain isomer of this compound. Okay, now when you do this, I know it sounds really simple, and but it's not multiple choice. Okay, so please be careful. So what I'm going to do is I'm going to give you 2 minutes. I know it's only 3 questions, but I'm going to give you 2 minutes because I want you to answer these. So here's the 6 compounds. Okay, and in those 2 minutes, I'll go between the 2 questions so you know. So there's my questions, and your 2 minutes starts now. Okay, so how do you go about answering a question like this? Because I'm pretty sure some of you are going, but 2 minutes wasn't long enough. Grade 12s, 2 minutes actually for a question like this, if I gave you time at the beginning, is more than long enough, okay? Let me show you how you go about answering a question like this. So we don't look at the question, we look at the table, okay? And we go, as soon as we see a table like this in question 1, I know it's going to be about naming, functional groups, all of that sort of stuff. So we go through each compound and we make decisions about it, okay? So we go, if we look at compound A, it has a double bond in it, so that makes this an alkene, okay? So I know which functional group it's in. Compound B has a triple bond that makes this an alkyne, okay? C has an OH at the end. That makes this an alcohol. This is 2,2-dimethylpropane. That makes it a haloalkane. Apparently, I've lost the ability to speak today. Let's not tell anyone. Then we look here and we go, oh wait, this has got the special one with the carbon in the middle. That makes this an ester. And now this one, F is a little more difficult because we look at it and we go, well, easiest way to decide on this one is actually to draw it out. So we've got CH3, CH, C, and then we have a CH3. So there's a CH, there's a CH. Actually, that's got a double bond in it as well, because otherwise the carbons don't have enough. So this is actually an alkene as well. Okay. Maybe we're going to be asked to name it. So if we quickly look at these and we go, well, let's just name them as well. My longest branch, my longest chain here would be this part. Okay. Let's just use this one. So that's 1, 2, 3, 4. That makes it bute. Okay. Bute, and 1, 2, 3, 1, 2. Okay, it's still going to be on 2 either way, so this needs to go on the smallest one, so that's going to be on 2. So this is butene, and it would be 2-methyl. Okay, so 2-methyl-butene, we're happy with that. Then we look here and we go longest chain. Oh, is that? Don't make that. That little CH3 at the bottom isn't a branch. So we go 1, 2, 3, 4, 5. 5 is, remember, it's meth, eth, prop, bute, pent. It's pent, and we know it's going to be pent something I. Oh, I'm not leaving myself space. Let's write that a little bit bigger. So that would be pent something iron, and now we go, if I number from the one on the left, 1, 2. If I number from here, it's 1, 2, 3. 3 is wrong. It's going to be 2-pentyne. Okay. Now we go to the alcohol and we go, okay, let's look. 1, 2, 3, 4. That makes it bute. Okay. The alcohol has to go on the first one. It's one of the rules. So this would be butane. Okay. 1-ol. Don't forget the N. Dimethylpropane, they might ask us to draw it. It might come up. So we go, well, dimethylpropane, I'm going to draw it. The top prop is 1, 2, 3. Methyl, dimethyl, 2, 2, so it would look like that. I'm not putting all the hydrogens in. This is just for me. This is an ester. Okay, remember the ester gets broken up over here. The one with the single bond oxygen is from the alcohol. That's first in the name, and it's 1, so this is methyl. Okay, 1, 2, 3, so this is methylpropanoate. Okay. 8, and then over here we know this was an alkene. If we name it 1, 2, 3, 4, that makes it bute. We're doing well. They're loving the bute on this one. 1, 2, or 1, 2. It's going to have to go on 2 butene. No, ene. Sorry, no, it's not. It's an alkene. So this is butene. Butene. Sorry, and the methyl group is on number 2. Okay. So we're doing well here. Okay, I know you can't really read it. Just go with it. Now, I know I've just spent 4 minutes, thereabouts, looking at this. Okay, but now watch how easy the next part of this becomes. Because now, write down the letter that represents the functional group, well, the compound. Slowly, there we go. That has a carbonyl group in it. Guys, remember the carbonyl group is from the ester. So it's this one, it's E. The carbonyl group is the double bond oxygen and the O. Okay, very, very important. Write down the one that is an alcohol. Oh, wait, that was C. Write down the one. Which one is a chain isomer of that? So, chain isomer, let's see what this is. CH3, that's CH3, C2CH3. So this is CH2, CH2, CH3. Now, a chain isomer means that we need to find something that has 4 carbons in it with the same number of hydrogens, all single bonds. And I look at these, well, it can't be A, it can't be B, can't be C, can't be E. We look at D, and it can't be F actually, because F is an alkene as well. Chain isomer means it has to have single bonds. So we look and we go, oh wait, those are all single bonds. It's D. Done. So much easier than what we did the first time. Okay, so I'm not going to give you as much time. So here's the next questions. So I want you to write down the IUPAC name of compound B, the structural formula of F, and the IUPAC name of a positional isomer of compound A. I'm only going to give you, mainly because 1.2.3 is a little harder, I'm giving you 2 minutes, and your time starts now. Okay, let's get this done. So the first question here was to write down the IUPAC name of B. So if we go back to the one where I wrote all over it, we go, look, oh, look here. I don't even have to think about it. It's right there, okay? So the IUPAC name of B is pent 1 ion. I don't even have to think about it because I've already done it. So my question here, that's pent 1 ion, okay? Then they want the structural formula of compound F. So if we go back to my nice one that I wrote all over, and we go find, oh, look at this. Look over here. I pretty much did it already. So now we're going to write it out nicely, and we recognize that it was actually 2-methylbutene, okay? So let's write it out nicely so that we've got space for it, so it looks nice, because at the moment that's just horrendous. So here we go. And the structural formula, remember, it was CH3. So there's my CH3. I'll put the hydrogens in a second. CH. Then there was another carbon. Then there was a CH. Oop, hang on. Carbon, yes. And on this carbon, there's a CH3 and another CH3. I should have done them a little bit smaller. So there's my CH3. So there's my CH3. This carbon had that attached to it, and this one had a CH, okay? This was CH, which means the only way this can happen is for me to have a double bond in the middle, and don't forget you have to give me all the bonds and all the hydrogens. Now they want the IUPAC name of a positional isomer of compound A. I want to go back to one of the tables where I haven't written all over it, okay? There's compound A. A positional isomer means that I have to move the functional group, okay? And I can either move it left or right, doesn't matter. at the moment, that functional group sits on the second carbon. I'm going to move it to the first carbon. So what I'm going to do over here is I'm actually going to draw it because it's easier for me if I draw it. So I'm going to go, well, I'm going to move it to the second carbon, and then this carbon had a CH3 on it. My next carbon, then I had another 2 carbons after that. Okay, so that would all have, that's what it would look like. But they didn't want the formula, they wanted the name. So we look and we go 1, 2, 3, 4. That's on the second one. So this becomes 2-methyl, watch, all one word, bute, 1-ene. Alrighty, so last one. This time I'm not going to give you as much time. Last one, I'm only going to give you a minute to do these ones, and off you go. Okay, grade 12's time's up, and I can just hear the wait. No, Tracy, we're not done. You're going too fast. Actually, you read in an exam, I wouldn't actually expect you to take more than maybe a minute and a half on this one because we've already done all the hard work. A lot of this is theory. So they asked you to which series compound E belongs. Okay, now remember, we did, when I wrote all over it, this is the part that was important. And what did we say? We said it was an ester. So it's done. The next part is straight revision. Name all formula of the catalyst. Now here you've got a lot of choices. You can tell me that it's either platinum or nickel or palladium. Okay? Learn the one that you can remember how to spell. Okay, so platinum is PT, nickel is Ni, and palladium, which I actually don't ever spell very often, is somewhere. Oh, no. Oh, I'm talking rubbish. Wrong equation. How many of you shouting at the TV going, Tracy, you're an idiot? Be nice. Oops. It's actually sulfuric acid. I'm just testing. Just making sure you know. It's the wrong one. It's sulfuric acid. Silly girl. Now, the name. Now, didn't we, when we go back to my original one, which I wrote all over, oh, look here. Look. I wrote it down already. It's methylpropanoate. So let's go back to the question and remember alcohol part, carboxylic acid part. What's nice about this particular question, is that they didn't ask you, come now, sure. They didn't ask you to do anything with the structural formula equations or anything like that. They just wanted the name. And esters are actually 2 words. It's the only one that you do is 2 words. So it's propan, propanoate. Okay, so I think I need a break. So that's where we're going to leave it for now. And then I'm going to see you in a couple of minutes and we'll do another couple of questions. So, grade 12s, we are now going to look at a question that has to do with trends, and the first one is really, really simple, and I'm going to give you 2 minutes to answer these questions, which is define the term boiling point, and what is the relationship between the strength of intermolecular forces and boiling points. Okay, so your 2 minutes starts now. Great. Okay, grade 12s, these two questions, just so you know, would be what we consider level 1. 2.2 might be a level 2 question. It's stuff that we expect you to know because it's no application. Now, be very careful with boiling point. They're becoming very, very sticky with it, and I'm seeing this question being asked lots, so I think it's quite important. Boiling point is not the point, be very careful here, at which a gas turns into a liquid. They will not accept that. That's a grade 8 to 9 definition, all right? First of all, it's not a point, it is a temperature. So the first thing they want is they need you to have the word temperature. Okay, so it is the temperature. Now watch what I'm going to say, at which the, now watch here, this is the important thing, the vapor pressure equals atmospheric pressure. Okay, that's when it starts to boil. That's actually quite important because water boils on Mount Everest significantly lower than 100 degrees because the atmospheric pressure is so low that the water starts to boil really, really quickly. Okay, it's like, I don't even think it's 10 degrees and it starts to boil because the vapor pressure equals the atmospheric pressure really, really quickly. All right, that's the first thing. Now, they ask you, what is the relationship between strength of intermolecular forces and boiling point? Guys, please be careful here in that you cannot tell me that they are directly proportional. Okay, now before you start to go, well, first of all, Tracy, you're spelling things wrong, so let's not worry about that. The problem here is the word directly. If I say something is directly proportional, what I'm saying is if I double one thing, the other thing will double with it. So if I'm saying, if I double, what directly proportional means here is that if I double the strength of the intermolecular forces, I must double the boiling point. That is not what happens. Okay, if we increase the strength of the intermolecular forces, the boiling point will increase. Okay, or what we can rather say is that they are proportional. Okay, that's a good way to put it, is to say that they're proportional, because that also tells me that if I decrease the strength of the intermolecular forces, then I decrease the boiling point as well. Okay, so use the word that they are proportional. Okay, so that was our theory part. Let's get to the meat of the question. Now it says the relationship between strength of intermolecular forces and boiling point is investigated using 4 organic compounds from different homologous, hate that word, series. The compounds and their boiling points are given. So there we go. All got 3. They're all prop. Okay. That's great. And now they say, so that's the thing. Now the first question is referred to the type and strength of the intermolecular forces to explain the difference in boiling points between A and B and C and D. Okay, so I'm going to go back here because I think you need to see this. So I want to know why A and B are different, and I want to know why C and D are different. And what you're going to do is you need to talk about the type and the strength of the intermolecular forces, okay? This one's a really, 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 really important question. So this time, because you've got 2 things you need to look at, I'm going to give you 3 minutes. Write it in point form. Please don't write paragraphs and essays. Science teachers don't like marking essays. We're terrible with them. So point form, please. Okay, you have 3 minutes and your time starts now. Okay, grade 12s, how did we do? Hopefully we did okay. Now, I like questions like this because when we do them, I'm really trying to impose on you the importance of learning the names of the different types of intermolecular forces. It's really, really important, okay? So we go back to the question, and the first one is the type and strength of the intermolecular forces between A and B. Now, if we look at A is an alkane, okay? B is a ketone, and remember with the ketone, you're going to have somewhere a ketone is going to have a double bond, or let's just put the carbon to an oxygen in the middle, okay? And in fact, propan-2-one would look like that, okay? In fact, I'm surprised they put the name in at all, because the number in at all, because it can only be on the second one. But first and foremost, propane has a significantly lower boiling point than the propan-2-one. That means it must have significantly weak intermolecular forces. Because it's an alkane, it means that it is nonpolar, okay? It's a nice nonpolar molecule. That means A has London forces. Or you can call it dispersion forces, that's fine. And some of you might have learnt it as induced dipole. That's fine. Okay, it has London forces. B also has London forces, but because of this, and that's the important thing, that double bond to the oxygen in the middle creates a dipole. So B has dipole forces, or dipole-dipole. Now, I have now referred to the type of forces. I've named them. You can't just say intermolecular forces. From here, and I have to be honest, I think they were a bit mean on the mark allocation here, is you go A, and you can either do it from A's point of view or you can do it from B's, but it doesn't matter. I do it from A's because it's the first one I mentioned. A has weaker intermolecular forces. All right. Therefore, lower boiling point. Okay. So just saying that you had London and dipole wasn't enough. You had to say that which one's stronger and which one's weaker. All right. Then we go to the next one, which was between the propan-1-ol and the propanoic acid. Now, this is quite an important one because propan-1-ol means this. So we have the OH, okay, and I'm not going to worry, I just want you to see it. Propanoic acid is this. Ah, that's not it. Okay, let's just put another C there. H, double bond O. Okay. Now, both of these compounds, and they've asked us lots, both of these compounds have hydrogen bonds. Okay, they both have hydrogen bonds. But, and we're going to start there, both C and D have hydrogen bonds. Okay? Have hydrogen bonds. So now we've got to say to ourselves, well, what's different between them that allows propanoic acid to have a much bigger, much higher boiling point? Well, watch here, okay? D has 2 hydrogen bonds, or has sites for 2 hydrogen bonds, okay? Why? Because of that and that. So because D has 2 hydrogen bonds, D has stronger intermolecular forces. I'm just going to call them IMFs, okay? Forces. Therefore, D has a higher boiling point. Okay. They love the difference between, I am going to put a dot in the eye if it kills me. They love the difference between alcohols and acids, okay? And that's a big thing. And it's a big thing that you recognize that the acid has 2. Okay, one more question. This one you can do quick. Here it is. Is compound B a gas or a liquid at room temperature? You have 1 minute to make a decision. And why? Off you go. Okay, so let's see what you did. I wish I could see your hands to see who said a gas and who said a liquid. But compound B, gas or liquid at room temperature? Well, first of all, we go back there and we say, well, its boiling point is 56 degrees. So under 56 degrees, it's going to be a liquid. Over 56 degrees, it's going to be a gas. And room temperature is defined as about 25 degrees Celsius. Okay, I do realize that some of us, that's not always true, but we go with it. So it's defined as about 25 degrees Celsius. So that is significantly lower than its boiling point, which means it's going to be a liquid. Actually, fairly straightforward. All right, I think it's time for a break. So I'm going to give you a couple of minutes, and then I will see you, and we'll do one more question. Okay, grade 12s. Now we have another flow diagram question. This time I'm going to help you a little bit before I just leap you into the questions, okay? So here we have, it says the flow diagram shows how prop 1-ene can be used to prepare other organic compounds. So we start with prop 1-ene and we make propane. The only way I can go to propane is it's from an alkene to an alkane. That means this is an addition reaction, okay? And I've added hydrogen. Okay, good. Then we go from prop 1-ene to an alcohol, and they want major product. We'll talk about those later. The only way that can happen is if I'm adding OH to this. Okay, that means it's also an addition reaction. Okay, and the opposite to an addition reaction when we go back to propene would be an elimination reaction because we're actually going to take water out. And so we probably didn't just add HO. This is a condition. So we probably did it with water. We'll look at that a little bit later. Then we've got, then this over here, we add HBr to it. That's obviously going to be an addition reaction again for that part. To go back to prop 1-ene, it has to be elimination again. All right. And we're going to break the double bond. This is going to make a haloalkane. Okay. Haloalkane. And then from here, we're going from a haloalkane to an alcohol. So E has to be substitution. In fact, E and F have to be substitution because from X to the alcohol, I'm taking a hydrogen and I'm taking a bromine off and I'm going to replace it with an OH. From the alcohol to compound X, I'm taking the OH off and I'm going to replace it with the bromine. Okay? So that's fairly straightforward. I'm not going to worry too much at this point about the major products because they may or may not ask it. So in terms of where we're going. So we've got what is happening. So the first question here is to write, oh, look here, I'm only going to give you a little bit of time. Write down the type of reaction represented by A, D, and F. I'm giving you a minute, and your minute starts now. All right, grade 12. So let's see how we did. So here we go. No, there it is. So 1A we said was addition. Now, if you wrote hydrogenation, I'd be happy with that, but they didn't want to know what type of addition. Keep it nice and simple. Then for D, remember, it's going from the haloalkane to the propene. That's elimination. And then for F, that was going between the alcohol and the alloalkane. We said that was substitution. Keep it nice and simple. Substitution, which apparently I've forgotten how to spell. All right, so next question. Now, write down the name or formula of the catalyst needed for reaction A, the name or formula of the inorganic reagent for B, the type of addition reaction for C, and then the name of compound X. So there's quite a bit there, all right? So that one's a little bit harder, so I'm going to give you 2 minutes, and your time starts now. Okay, grade 12. So let's see how we did. Okay, now the first one was name the catalyst or give the formula for reaction A. Reaction A was addition. Okay, now this one is the catalyst I tried to give you earlier. It's platinum, nickel, or palladium. Okay, just remember the one you can spell. Okay, I would never put palladium, I have to be honest, if I had a choice, just because I can't always remember how to spell it. Palladium. Okay, so that's easy. Name or formula of the inorganic reagent needed for reaction B. Reaction B is going from the alcohol to the propene. That was the elimination. Whenever that happens, we're taking out water. The thing we use to take out water, sulfuric acid. Okay? Yay. Type of addition reaction represented by reaction C. So reaction C, I'm going from an alkene to an alcohol. I'm adding OHs to it. The only way that can happen is by adding water. So this is known as hydration. Okay. Then they say give the IUPAC name of compound X. So we had propanene and we added HBr. So here, you really, I've done it again. Look at that. Oh, no, come now. Sorry, there we go. Now, because we want to, I've gone to the wrong one. There we go. Sorry, trying to extend pages, and now we're doing all sorts of things. There we go. Let's do it here. So, For compound X, when we look at it, the easiest way to do this is to go, well, I started with propene, so 1, 2, 3, and it was prop 1N, so there it goes, with all our hydrogens. Okay, so they would look like that. HBr comes along, and the HBr needs to split up, so I know I'm going to get propane. This is about making a decision as to where the bromine goes. Now, this is Markovnikov's rule, and basically, hydrogen is a bit of a snob. Okay, it's the only way I can describe it, in that hydrogen has to now make a choice and go, well, do I want to be with the carbon with lots of hydrogens or the one with not so many hydrogens? Well, you know, it's a bit of a kugel. So it goes, I want to be with the hydrogens. So the hydrogen from the HBr will go on that carbon, and the bromine goes on the second. That's the major product. That's really, really important for you to get. Okay, is that the hydrogen from the HBr will go into the carbon that already has a lot of hydrogens on it. If it doesn't matter which one it goes on, then it doesn't matter. There won't be a difference here. So my name of my major product, I'm determined to keep doing that bottom thingy there for some reason. So the name here becomes 2-bromopropane. Okay, now we're sort of running out of time. There's a couple of extra things here that we need to look at, and I want to first look at, I'm not going to worry about 3.3. What I'm more worried about, just quickly, because we're running out of time, is 3.4. Tells you both reactions, D and E, take place in the presence of a strong base, because D is elimination and E substitution. How do you tell the difference between them? Strong base is very important, but your elimination reaction, okay, so how do we get that we'll favor D? Okay, so D is the elimination reaction. The elimination reaction must have the stronger conditions, if that's a good way to put it. In other words, D must happen at a higher temperature. Okay, that's the first thing. So it happens at a higher temperature and with a concentrated base. Okay, that's really important. That's how you tell the difference, even if they give them to you. If it's a lower temperature and a dilute base, then it's substitution. Okay, if we want elimination, which takes more effort, it has to happen at a higher temperature and a concentrated base. Now, for reaction B, that was quite easy. That's the alcohol becoming your propene. Hopefully, you wouldn't have too much of a problem with that. Please just remember, though, that one of your products has to be water, not just the propene. Okay, organic chemistry. Practice, practice, practice. Know your naming, know your structures, know your trends, okay? And then you should be fine, because they really can't ask you that much, but you've got to know it well. All right, grade 12s? That's all my time for today, and I'll see you again next time.